At first glance, Comet 3I Atlas does not look special. It appears as a faint blur in the darkness of space, with a thin tail stretching behind it. If you did not know anything about astronomy, you might assume it is just another ordinary comet, like the many icy objects that regularly pass near the Sun. There are thousands of comets, and most of them are well understood. They come from the outer regions of our own solar system, heat up as they approach the Sun, grow a glowing tail, and then disappear again into the cold. But Comet 3I Atlas is not ordinary. What makes it different is not how it looks, but where it comes from. Scientists have confirmed that this object did not form around our Sun. Instead, it came from another star system entirely. It is an interstellar object, a visitor from far beyond the boundaries of our solar system. That single fact changes everything. When people hear interstellar object, their imagination often jumps to science fiction. They think of alien spacecraft or mysterious technology. But the reality is quieter and, in some ways, more unsettling. Comet 3I Atlas is most likely a natural object made of ice and dust, just like many comets we already know. What is disturbing is not what it is, but how easily it passed through our neighborhood without being noticed at first. This raises an uncomfortable question. If something from another star system can look so normal, how many others have already passed by without us realizing it? To understand why Comet 3I Atlas is special, we need to talk about orbits in simple terms. Objects that belong to our solar system move around the Sun in closed paths. These paths are usually circular or oval-shaped. Even comets that travel very far away are still gravitationally tied to the Sun. They may take thousands of years to return, but they always do. Comet 3I Atlas does something different. Its path is open, not closed. Scientists call this a hyperbolic orbit. This means the object is moving too fast to be held by the Sun's gravity. It came in from outside the solar system, passed through once, and will leave forever. It is not coming back. This is how astronomers know it did not form here. There is no known way for an object born in our solar system to gain that much speed naturally. The only explanation is that it was formed around another star and later thrown out into interstellar space, drifting for millions or even billions of years before crossing our path. This discovery places Comet 3I Atlas in a very small and exclusive group. Before it, only two confirmed interstellar visitors were known. Oumuamua, discovered in 2017, and 2I Borisov, discovered in 2019. Comet 3I Atlas is the third confirmed interstellar object ever observed. When Oumuamua was discovered, it caused excitement and controversy. Its shape, motion, and behavior were strange, and some scientists publicly debated whether it could be artificial in origin. That idea was later dismissed by most experts, but the mystery captured public attention. Borisov, on the other hand, looked clearly like a comet. It had gas, dust, and a visible tail. It behaved more or less as expected, except for the fact that it came from another star. Comet 3I Atlas is different in a subtle but important way. It looks normal enough to be ignored. If scientists had not carefully calculated its orbit, it might have been classified as just another local comet and quickly forgotten. This is what makes researchers uneasy. If interstellar objects can hide in plain sight, then our records of space may be incomplete in a serious way. We may have already observed other visitors from distant stars and mistakenly labeled them as ordinary solar system objects. In other words, the universe may be passing through our front yard far more often than we realized, and we have only recently learned how to notice. Many people assume that modern astronomy sees everything. We have powerful telescopes, computers, and satellites. But in reality, our detection systems are limited and biased. Most sky surveys are designed to find dangerous objects, such as asteroids that could hit Earth. Systems like ATLAS, Pan-STARRS, and ZTF scan the sky looking for fast-moving points of light that come close to our planet. They are excellent at their job, but they are not optimized to find faint, fast objects coming from unusual angles. An interstellar object like Comet 3I Atlas has to be lucky to be detected. It must be bright enough, pass through the right part of the sky, and do so at a time when telescopes are looking in that direction. If any of those conditions are not met, it will pass unnoticed. This means the three interstellar objects we know about are almost certainly not the only ones. They are simply the ones that crossed our limited field of view. Many more may be passing through the solar system every year without detection. Scientists now believe that interstellar debris is common, not rare. Our solar system may be constantly intersected by fragments from other planetary systems. Interstellar objects are valuable because they are physical samples of other star systems. Normally, astronomers can only study distant planets and stars through light and models. But an interstellar comet carries real material formed around another sun. By analyzing the light reflected and emitted by Comet 3I Atlas, scientists can identify the chemicals in its gas and dust. So far, its composition looks similar to comets from our own system. This suggests that the processes that form comets may be universal across the galaxy. That idea is both comforting and humbling. It suggests that our solar system is not unique, and that the building blocks of planets may be common everywhere. At the same time, it raises deeper questions. If material from other star systems regularly passes through ours, could it sometimes collide with planets? Could it deliver complex molecules? Some scientists cautiously revisit the idea of panspermia, the theory that life's ingredients may travel between star systems. There is no proof that this has happened, but discoveries like Comet 3I Atlas make the idea less easy to dismiss. One of the most powerful effects of this discovery is psychological. Humans like to imagine the solar system as a closed home, protected by distance and emptiness. Comet 3I Atlas reminds us that space is not static. It is a highway, not a museum. Fragments from other suns cross our orbit. They move silently, invisibly, and without concern for human ideas of borders or ownership. Our solar system is not a quiet corner of the universe. It is part of a larger flow of matter moving between stars. This does not mean danger is imminent. Comet 3I Atlas poses no threat to Earth, but it does change the story we tell ourselves about where we live. In the near future, new observatories will dramatically increase our ability to detect faint, fast-moving objects. The most important of these is the Vera C. Rubin Observatory, which will scan the entire visible sky repeatedly with unprecedented detail. When it begins full operations, astronomers expect to discover dozens or even hundreds of interstellar objects. At that point, Comet 3I Atlas will no longer seem rare. It will look like an early warning that we were slow to understand. As detection improves, our understanding of the solar system will shift again. We will move from asking whether interstellar visitors exist to studying how often they come, where they originate, and what they carry. Comet 3I Atlas will fade from view and continue its lonely journey through interstellar space. It will never return. But the questions it raises will stay. It reminds us that the universe is not distant and abstract. It is active, connected, and moving. Other stars are not just lights in the sky. They are sources of real material that can reach us. The comet does not tell us everything. But like a message in a bottle, it proves that exchange is happening. We are not as isolated as we once believed. And perhaps the most unsettling thought of all is this: Comet 3I Atlas is only the one we noticed. Many more have likely passed before. Many more are passing now. And many more will come whether we are watching or not.